Now let's look at the quotient property of square roots. And it says that if we have the square root of a fraction, we can separate that into the square root of the numerator over the square root of the denominator, where the numerator, the radicand, is equal to or greater than 0, and the radicand in the denominator must be greater than 0. So let me show you some examples of how we can apply the quotient property. Some of the easiest problems you'll get will look like this. The square root of 4 over 49 can be separated into, the square root of 4 over the square root of 49, which gives us 2 over 7. And this is now simplified. We could also get the square root of 23 over 64, which separates into the square root of 23 over the square root of 64. Now 23 only has the factors of 1 times 23, so this is already in its simplest form, and the square root of 64 is 8. Since I now have a whole number in the denominator, it meets the criteria. There are no fractions in the radicands and no radicals in the denominator of a fraction. So we are in simplest form. I'll show you a couple more examples. Let's say I have negative square root of 144 over 4k squared. So I'm going to use both the quotient and product properties for this one. First, I'll separate my numerator and denominator, and I'm going to separate my denominator into its two factors, the square root of 4 times the square root of k squared. So that right there is my product property at work. I can rewrite this as the square root of 144 is 12, square root of 4 is 2, and the square root of k squared is k. So we're almost at simplest form. What we can actually do here, though, is now simplify by dividing. 12 divided by 2 is 6, 2 divided by 2 is 1. So we can rewrite this as 6 over k. Whoops, and I had a negative sign at the beginning, so I need my negative sign there. It's outside of the radical, so we can do that. And I'll try one more. The square root of a cubed over 121. So I'll use the quotient property to separate those. The square root of a cubed over the square root of 121. Now I'm going to use a product property and separate this into a squared times the square root of a, and then the square root of 121 is 11, because 11 times 11 is 121, and the square root of a squared is just a. So we have a times the square root of a over 11. Okay, there's that. I want to show you real quick. This is how I learned it, and it's another way you can do it too. My math teacher taught us to expand our numbers, or our values. So the a cubed would have gotten expanded here, and then since we're doing square root, we were told to do that. So take our two factors or groups of 2, and then for every group of 2 we can take one out because we know that's the square root of this squared. I like the way I'm teaching it better. I think it makes a little bit more math sense, but just so you know, if you're having trouble or if you want to do it a different way, you can do that as well. Either way, you end up with the same answer. Okay, and that's now simplified.